So this next presentation is presentation 2 of altitudes on page 189. Make sure you can see that. There we go. Okay, and it is to take a look at different altitudes. Sometimes the altitudes will be inside the triangle, sometimes they'll be outside, depending on the type of triangle. So we're first going to choose an isosceles right triangle. I've actually made mine out of the sticks. So here's an isosceles right triangle. Now, something I want to point out about the sticks. You see my bottom stick, right, which is my, actually right here, my hypotenuse. So the hypotenuse sticks are special sticks in the triangle box, and they are these, you have a whole set of them. They're these ones that don't have any color. They're just plain wood. All right, and these are meant for right triangles. And the reason for the different sticks is because if you use these, you'll be assured to have a right triangle. I also have a measuring angle, which I'm going to use as I make these to make sure that they're right and to prove to the kids that it is in fact a right triangle. All right? Okay. Usually the geometry sticks usually comes with a measuring angle, and it's red. It's a nice plastic red thing, but I made my own because this box of sticks didn't have it. All right, so we're going to need that, and we're going to need our plumb line. And we're going to start with an isosceles right triangle. You would label it for the children, and say, okay, we want to find the altitudes of the three altitudes of this triangle. So we're going to start measuring it this way, and I place my plumb line right at the vertex, and I see that I get an altitude. It's fairly short, and it's on the inside of the triangle, right? The altitude's on the inside, just like it was in the last presentation. All right, now I'm going to go on one of the equal sides. And if I ask the question, is it on the inside or the outside? The answer is neither. It's along one of the sides. Okay? It's along one of the sides. And if I measure the other side, I'm going to find the same thing. Okay? The altitude is actually along one of the legs of the triangle. All right, so this has both an internal altitude and along the sides. All right, so next I would like to take let's take an equilateral triangle. So I've also made an equilateral triangle, which is right here. Here's my equilateral triangle, and I'm going to go ahead and measure, and that is an interior altitude. And you can see, just like my acute triangle of the last presentation, all three altitudes are on the inside. And that's actually going to be the case for all acute triangles. All three altitudes will be on the inside. All right? Okay. Next, I'm going to take a scalene right triangle. All right, so here's my scalene right triangle. All right, and again, I used the wooden sticks with no color for the hypotenuse. The hypotenuse, of course, is the side opposite the right angle. And again, I want to prove to the children that this is in fact a right angle. And when I measure the sides, the altitudes, I'm going to see that one is on the interior, one is on one leg, and one is on the other leg. Okay, so just like the other right triangle, I might be able to make a case right now that for right triangles, you would have one interior angle and one interior altitude and two on the sides. All right, and then we actually did two acute. I'm going to pull out my acute from the last presentation. These had 3 internal, and finally I would like to look at my last triangle, which I have, which is a scalene triangle. I'm sorry, an obtuse scalene triangle. All right, obtuse scalene triangle. All right, so this one then becomes a little bit different. So this is an obtuse. Let me move these aside and put these together with these. All right, and we can label them in a minute. All right, so here is an obtuse scalene triangle. And what makes it an obtuse is that it has one obtuse angle, namely that it's larger than 90 degrees. So again, if you want to use your measuring angle to prove that it's greater than 90 degrees, you could, go away, you could show it this way. So you see that this is not along this side, it's bigger than a 90-degree angle. Okay, so this is an obtuse triangle, and I think if we look at the altitudes, you'll see that one of the altitudes is interior, but the other two are actually going to fall outside of the triangle. So this one falls outside, and even this one falls outside. All right. So an obtuse scalene triangle has 2 external altitudes and 1 internal. All right, so I want to go ahead and summarize this. So I'm going to write, and I would say this is either a second or third level lesson, probably third level, maybe second. Okay, so I'm going to say that an obtuse scalene, all right, and I'm actually going to draw. Okay, and I have, let me draw this 3 times so that I can show all 3. And this will be the interior angle. Let me just fold that up so you can see it. Okay, this will be the interior angle of my obtuse scalene. All right, and then I'm going to draw it again. And this time I'm going to draw it this way. This is in your album, a little sloppy. And what we really need to do is we need to extend the base. I'll show you in 1 second. We need to extend the base so that we can draw the altitude, the exterior altitude. There it is. All right, so that was the second altitude we measured. And then finally, we're going to draw it, sorry, I got my covers mixed up, so I'm getting my colors mixed up. There we go. We're going to draw the third altitude that we measured, which was also exterior. So there are my 3 obtuse scalene altitudes, 1 interior, 2 exterior. All right, and so we'll put that here with these. All right, and then I want to look at my scalene right, which is right here, my scalene right. I'm going to draw the 3 once again. So I'm going to draw it this way. This is scalene right. draw the second one this way with one of its sides as its base, and then the third one is going to be this way with one of its sides. Okay, so in the first case, I'll show you this in one sec. The altitude is right there, and in this case, the altitude is right there. So these are what's happening with our scalene right triangle. We found that we had one interior altitude, and the other two altitudes were along the side. All right, so we are going to put that down here. I'm going to get rid of this for now. Put that right there. Okay. All right, and then we had our equilateral triangle, which is right here. I'm going to draw my equilateral triangle, and it doesn't matter which way I draw it. Doesn't matter which way I draw it. Sorry, oh, the bee just landed on me. Gosh. All right, it doesn't matter. I'm just going to draw one because it won't make a difference. All right, and all of its altitudes will be interior. All of its altitudes will be interior. All right, that's here. And finally, I have, well, no, this one goes with this one because it's another right triangle. And then it's really not that it's equilateral. It's also because it's acute. So let's write equilateral acute. All equilateral triangles are acute. All right, so all equilateral triangles will be acute. So there you go. There we have our three different types of triangles and their altitudes. The next presentation I'm not going to show you because it is very self-evident. It is, what you do is you take the triangle drawer and you measure all of the altitudes of all of the triangles in the triangle drawer of the geometry cabinet. All right, and instead of making this a presentation, you can just go ahead and assign it to the students. They need to take all the altitudes, trace them onto their geometry notebooks, label all the altitudes, do it with a friend so they can help each other measure. You can even have them take a ruler and actually measure what the altitudes are and record them. All right, so that would be the following either presentation or follow-up. All right, thanks.